Okay, good morning, pre-calculus. Today we're going to be looking at 11.2b, which is one-sided limits. So with one-sided limits, you're actually looking at what happens as a limit approaches from one side and as it approaches from the other side. So it's pretty similar to what we've been doing. So let's go on ahead and take a look at what some of this says. So it says the limit as f of x approaches, as the limit of the function f of x, sorry, as x approaches c from the minus, that means from the negative side or from the left, and the limit of the function f of x as x approaches c from the right or the positive side. Okay, so those are our one-sided limits. So we're going to be looking at both of those. Okay, so this first one right here, let's take a look. The limit as x approaches 0 from the left of the absolute value of 2x over x. So we're going to go on ahead and graph this. So y equals clear. So I'm going to put in my absolute value. Let's see, number, absolute value. Okay, so in case, I guess, let me show you guys in case you guys did not see that. So I'm going to go to math, number, and I see that absolute value, okay, 2x parenthesis, okay, then I'm just going to do divided by x, okay, so that's how I'm going to do that. All right, so the absolute value of 2x divided by x. All right, I'm going to graph it. Okay, now you can see that there's two different lines here. So when we looked at this in the very beginning and we said we're using graphs or tables, this would have shown a does not exist, okay, because it does not approach the same number from both sides. But now we're looking from just from the left. So just from this side. So we're going to go ahead and go to our table and we're only going to look at from the left. So from the left, it's approaching -2. Okay, so our answer is going to be -2. And then the same thing on the right, we don't even have to regraph it. So from the right, it's approaching +2. All right, so not too bad. Okay, so we're seeing what value is it approaching from the left and what value is it approaching from the right. So +2 from the right, -2 from the left, but right at 0 because it stops and it has a big jump there. It's an error. So let's take a look at this next one. It says existence of a limit. Okay, so if f is a function and c and l are real numbers, then the limit of the function as x approaches c equals l if and only if both the left and right limits are equal to l, to the same number. Okay, so that's what we have to see. We have to see, are these equal to the same number? Okay, so let's go on ahead and take a look at this next one. So it says find the limit f of x as x approaches 1 for these two functions. Okay, so I'm going to graph my first one first. Okay, and let's see, y equals, oh, I got to clear it out. Okay, so I'm going to do 4 minus x. Okay, and let's see, so 4 minus x, and I'm going to graph, okay, and I'm going to hit my table, and I can see that as I approach +1, oh geez, let me get closer to +1, so point 0, oh, point, let's go with 0.995. All right, so as I get really close to 1, hey, I'm going to get to 3. And I could also do this one. I could do the limit as x approaches 1 from the left, okay, of 4 minus x. And I could do direct substitution here. So I could do 1 here, and I would get 3. Okay, so either way works. Okay. Now let's go on ahead and let's plug in this other one. So 4x, so I'm going to do the limit now as x approaches 1 from the positive side, okay, because this is positive, of 4x minus x squared. Okay, so remember, this is a piecewise function, so this is one graph. Okay, so this one right here, if I plug in 1, okay, so I'm going to get 4 minus 1, and I'm going to get 3. So then my limit as x approaches 1 for this whole thing is going to equal, not 1, it's going to equal 3, because it does approach 3 from both the left and from the right. All right, let's take a look at looks like a word problem here. So it says an overnight delivery service charges $8 for the first pound and $2 for every additional pound. Let X represent the weight of the parcel and let F of X represent the shipping costs. Show that the limit as X approaches 2 does not exist. Okay, so now we need to come up with our values here for this limit. Okay, so if we think about this, so for the first pound, so our function f of x is going to equal $8 from 0 to and including 1 pound. But then for the next pound, so from 1 pound all the way up to, oh, not including 1, for 1 pound all the way up to and including 2 pounds, it's going to equal $10, and so on and so forth. So 2 to 3 would be 12. Okay, so this is actually a step function or a piecewise function. So it starts here, and then for the next pound it goes there, and then for the next pound it goes there. Okay, so this right here, let's take a look at this graph. So if we're coming from this side and we're coming from this side, it is not ever going to approach the same number, okay? Because as x approaches 2, okay, so this is going to be 2 is less than x is less than or equal to 3, okay, for $12. So as x approaches 2 from the left, it's going to be 10. And as x approaches 2 from the right, it's going to be $12, okay, because it's that $12 there and it's that $10 there. Okay, so this function does not exist, okay, because it does not approach the same number from both sides. Okay. So you're going to have to pay close attention to those piecewise functions, okay, step functions that we learned. All right, so let's go on ahead and take a look at using the difference quotient in calculus. So this just says that the function is x squared minus 1, and we want the limit of this right here. Okay, so all we're going to do here is we're going to take this in pieces. Okay, so the first thing I'm going to do is I'm going to find f of 3 plus h. Okay, and I have some extra workspace because this might take up a little bit of room. So f, and here I'm going to put a 3 plus h. So anywhere in this function I see an x, I'm going to put a 3 plus h, so that's 3 plus h squared minus 1, which is really 3 plus h times 3 plus h minus 1. So that's going to be a 9 plus a 3h plus a 3h plus h squared minus 1. So that is going to be h squared plus 6h minus 8. Okay, so that's just that first part. But then I have to subtract f of 3. Okay, so this is my f of 3 plus h. I'm just going to write that down. So now my f of 3, anywhere I see an x, I'm going to plug in a 3. So 3 squared minus 1. That's going to be, oh, that was a plus 8, sorry. So that is going to be a 9 minus 1, which is going to be a positive 8, but I'm subtracting it. So I'm going to subtract that 8 there. Okay, so that goes away. And now I am left with, I'm going to go back up here now. So now I'm left with h squared plus 6h all over h. Okay, let's pull an h out of here. Let's factor. So now I'm going to be left with h plus 6 all over h. That h is going to go away. Okay, so I have no h on the denominator. So now I'm left with the limit as h approaches 0. Okay, of h plus 6. Okay, so now I can plug this in and I'm going to get the value of 6, okay? So using the difference quotient, I have to plug in each of my individual parts, okay, and then solve it at the end. So remember, all this means is that anywhere I see an x, I'm plugging in 3 plus h. All this means is anywhere I see an x, I'm plugging in 3. It's two different parts, okay? Two, essentially kind of like two different functions, okay? So I think that is it, yep, for this section. So go ahead and do your assignment, and I will see you guys next time.